Jay is the one of the principals of Facility Dynamics. He also teaches at a lot of universities. University of Wisconsin is one of them for sure. And his company, Facility Dynamics, specializes in consulting on controls, BAS controls, and also commissioning. And they just finished, I guess it's okay to mention that you just finished the Apple project, which is a very large project. So it was something to get that job for sure. And with that, here is Jay.
Thanks. Thanks, Chuck. All right, fun. Is that better? I'm having ice cream. Okay, really close. How many of you have heard me speak to you before? Maybe half of you. I looked at what the topic you all asked me to do, and it's very similar to what I did 3 years ago. And I kind of did an update to that in this BAS world. So took a look at some things and I give you my perspective to our industry. So I'm always, I look at your agenda. I wish I could spend the week for your conference here, but it always amazed at what you all pull together at the community college, technical college level, without the resources of what I get involved in some of these major grants to do things, and you're going to go up to LB&L, and I look at the money that's spent on some of these things, and so it's pretty impressive what you all put together, and I think it's really neat that you share that information here. Because I truly believe the answer to the problems that we have in their buildings is a people. It's an educational problem, and I'll talk a little bit about that in this. So my perspective, I think we kind of know what the needs are out there. Big perspective. I'll give you a little bit of my, what I've seen over my career, because unfortunately I've been involved with it for over 40 years now, and people like Mark. As well, who Mark and I crossed paths. We figured out later in high school. We knew each other at the state of Delaware, where we worked as a consultant at the state, and Mark worked at the state. And in conversations, he grew up in Warren, Rhode Island. I grew up in Middletown, Rhode Island, and we both graduated the same year, and we both played baseball. And we were in the same division, so there's a good chance that I pitched against him back when we were 17 and 18 years old. So here's, 45 years later, we keep running into each other, and it's sort of a small world. But it's, you get perspective. You've got this 40-year career, and I'll give you a little bit of background. First, talk to you what I want to talk to you. I'm going to give you a little bit about a history of what I see happening in our industry, and this is related to what the needs are today. I'll look at overall trends and some of the realities of our industry, and then the educational needs. Turn the sound off on that. And where do we go from here? So my perspective, because again, my opinions are based on where I've been, right? So just not to give you a big background thing, but this is where I've lived. I started in the Air Force doing design work on HVAC. I was a mechanical engineer, ROTC student, and I needed the scholarship, is why I went to the Air Force, and the Air Force was sort of the least military of the organizations. So in the Air Force, as a mechanical engineer, you can either work on F-16s or really cool stuff, or you can, there's this really small number of mechanical engineers that did HVAC design. So as a 20-year-old, do you want to work on, fighter planes or air conditioning? It's like, so you don't take the HVAC course as an elective in the program because they might put you in facility engineering. So I avoided that, figuring that will increase my odds. See how successful I was in doing so. I got into civil engineering squadron, which was doing mechanical design work, which was fortuitous looking back. The best way to get out of that field was to go get an advanced degree. So they had a program where they sent you back for a master's. And if you had a master's degree, there was almost no use of a master's degree in HVAC design work. So I was going to go teach at the academy and segue into R&D, where there was lots of needs for advanced degrees. They had a really cool job in foreign technology division, which you kind of analyze what other people were doing. It sounded that's kind of what I wanted to do. Except there was one job, and that was teaching HVAC that required a master's. And bingo, I found myself at the Air Force Institute of Technology teaching HVAC design and HVAC controls. That's where I learned how to speak and talk, and which is a tremendous gift. You all eventually, obviously, you all do that. So that was good, and I still hadn't given up, and I actually was. I tried to become a mission specialist in the space shuttle program, and my board was due to meet in March of the year the Challenger accident occurred, so they canceled everything. So then they offered me a job in Turkey, supervising maintenance of radar sites, and it involved flying on Turkish C-130s that made a lot of unscheduled landings in the desert, is what my guy told me that about it. And I went, I didn't think that was a good use of my 9 years of skill set I learned, and so I left and went to the outside. I worked for an energy services company for a year or two. They taught me how not to treat people and not run a business, and my Portuguese mentality, I quit and started this company 30 years ago. That's how we are. So my current focus, so I've been an owner, and I think that's important. I had a mechanical superintendent that had just knocked out a wall and replaced a coil, and swore to the next lieutenant that walked by that he was going to show him that you have to consider operations and maintenance. I was that guy, and I ended up spending half my days in the shops in the afternoon, which was, I did it because I was bored, but it really was very fortuitous for me to spend half of my time, my first 3 years, in the field, in the inheriting side of the world. So that also was just lucky more than anything else. My current focus is I do a lot of BAS and DDC master planning, which is an educational thing. You've got to educate owners on what the truth is about open protocol, mostly what are the not truths of what open protocol is. And because the decision makers are not experts about this. And so I spend a lot of time, and that's an educational thing. I play around in fault detection, implementation, and I do some teaching and sort of oversight of a lot of on the commissioning side. Do a lot of retro-commissioning projects. This is the Marine Corps base in Hawaii, one of my favorite places to do retro-commissioning work. Just got a text that we got a next phase of a job at Schofield, which is also on Hawaii, and it just blows my mind how much retro-commissioning work we do on island. It's 30 cents a kilowatt hour for electricity. That's the high volume commercial rate. It's 35 on a residential, and it's like 40 something out in Maui and Kauai. And it's a lot of cooling load hours. So it's crazy expensive. The winter design here is 60. The summer design is 85. The typical unit has a 2-position outside air damper and a cooling coil. And a cooling only VAV box, because you're not going to put reheat in. But their biggest problem is on that 64-degree winter day, with the trade winds coming in off of the coast, you have a cooling only system with no heating. If it goes to minimum, what's going to happen to your space? You overcool. A tight building in Hawaii keeps the bugs and lizards out. Truly, because the climate is not harsh, so they don't build them tight. So you're in a 63, 64-degree day, overcooling the space, and your enclosure's not tight. What happens? We have science experiments everywhere, in our walls and everywhere else. That's one of their biggest problems, frankly, is how do you deal with that? And the solution, if you look back, because I'm looking back at what do we used to do, is a cooling only, a basically dedicated outdoor air unit that basically pre-cools, dries everything out, and then recools. That's what they did in all the large buildings in the 60s. But now we don't spend that money. We just slap in a cooling only VAV on a porous building, and we end up with all kinds of problems. So kind of perspective to that. And then on the new construction, Chuck mentioned this project. We just finished this job. So we get, we do schools and universities and BSL 3 and 4 labs. We do complex things. We're doing most of Google data center work right now, and that. So we get involved in the big money jobs and the little ones. And I can, you'd think, are the problems anything different here? And I can tell you truly, they're not. Same challenges on what, I don't know what the value of this project is. The internet says it was $5 billion or something like that. But, we have the same challenges no matter what we do. Okay, so let me look at the controls design stuff and talk about some perspective. I came in the industry in the 70s, and I could look back at what was done in the 60s. And if you look back at what was done on the 60s from the controls perspective, as a design engineer really designed the details of controls. The systems were very simple, a lot of constant volume, a lot of reheat, a lot of multi-zone systems, much simpler than today's systems. But the engineer really designed the pneumatics as part of the design documents in the 60s and was very engaged in the turnover of the project. The engineers were heavily involved in the construction administration side. They were very active in the field, and they basically self-performed balancing. A lot of the engineers would tweak the system. They knew their design was a wild-ass guess, and it was really good in January and July, but we used to, when I came in, even in the 70s, we did part load psychometrics by hand. We analyzed what's going to happen in the spring and the fall when we're not at 95 or whatever the winter design is. Today, the model does that for us, or some happy, crazy answer. We don't have that anymore. And the focus was on comfort. Just get it to work. We didn't care about energy because we were paying a kilowatt, penny a kilowatt. Nobody was focused on the energy in the 60s. As 70s came on, we dealt with our first energy crisis, and we moved away from detailed controls design into performance specifications. But at that time, and especially in the early 70s, the engineers were still around who had done design, and so performance specifying didn't work too badly there because the engineers had the skill set to look at a submittal to meet their performance and did it work. And slowly, the degradation of that skill set and then the transfer from pneumatics to DDC led us to the mess that we're in right now, in my opinion. So again, in the 80s and 90s, having lived through that, I lived through the still completion where pneumatics was dominant and the overlay early generation energy management systems, still mostly performance specs, but that experience was retiring and fading away. We really had these overlay BAS systems that were specified and designed and conceptualized by computer folks because they were heavy computer with data gathering panels. Anybody old enough to remember those kind of days? It wasn't true DDC. You still had underlying pneumatics and some resetting that occurred and turning things on and off. Some very expensive time clocks is what they ended up being. And you still had the underlying pneumatics under the system. So we ended up with a lot of overridden systems out there and things like that. So we lived with that in that time frame. I remember when we were at the Air Force Institute of Technology teaching, it was in the mid-'80s, and we had 3 schools. We had a school of engineering, a school of systems and logistics, and a school of civil engineering. The School of Civil Engineering did continuing education. We did 1-week, 2-week, 4-week classes where people would come from the field for a long period of time, and we would teach them. So it was much more like continuing education. The other programs were resident-type programs with very little continuing education. But we got a phone call one day from a guy we knew who was a computer jockey over at System and Logistics. He taught computer software and that kind of stuff over there. And he called us and asked us, we just heard the guy call. We had kind of a bullpen, 4 guys, and we always would relay what that call was. And the guy had called and was asking us if it was okay to duty cycle chillers. And we could hear our peer explain to him why that was a bad idea, and you couldn't do that. We're just, we're moth to flame. Somebody asks us a question like that, we just answer it and tell them in glorious detail why that's a bad idea and why you can't do that, and so forth and so on. Then I hook up the phone and he repeats that to us. This is what the call was. And then I asked the important question, like, why did he want to know? And he went, oh, I forgot to ask him, and called them back. And he was writing the tri-service spec for the early overlay building automation systems. It didn't understand that it would be a bad idea to duty cycle chillers or other equipment as well back in the day. So we had this time frame, we had sort of this mixed people that were involved in our thing who don't really understand the applications that were designing the solution for these computer-based monitor systems. So we had a decade of that going on, which was problematic. And then we got into our first generation DDC stuff, which was expensive, the old JC85 and stuff way back when. And it was all hardware upgradable, so it was sort of not cost effective long term. I was involved with the DoD recommending that we put a ban on DDC from the mid 80s through the late 90s, which was actually a good thing because we closed a lot of bases in that time frame, so we didn't waste a lot of money. But my main issue was the hardware we could purchase in 1991, 92, controls-wise, had a lifespan less than the equipment. You know, when your controls only lasted probably 5 to 10 years before you wanted to throw it away, and your rooftop unit was hopefully shooting for 2025, that's a problem. And we basically said we're going to live with pneumatics until that is more robust, which happened somewhere around the turn of the century. You know, early 2000s, I think we got to most things being software upgradable, and they lasted a little bit. And you know, we've lived through this, you know, attempts to do open protocol. That's been a big focus. Now the new focus is on cyber stuff. That's a big, big focus out there. Everybody's scared about somebody, you know, blowing up the boilers. They don't understand about manual safeties and things like that. But you know, you go to some of these IT cyber meetings, and it's scary, their knowledge. Well, what if they make it 200 degrees in the classroom, which we would enjoy right now here? But they literally, I'm not smart enough to make this stuff up. These are real comments. They could hack in the system and make it 180 degrees into space. Or they could blow the boilers up. It's like, really? I doubt the Chinese are really interested in that. And, you know, and the way the military is approaching cybersecurity is they're drawing a box around the whole base and making the whole base secure, where 98% of the facilities do not need that level of security. What are you gonna do to a barracks with a bunch of Marines or airmen in it? What are you gonna do? Make it hot? You think that's their focus, is to hack in there and turn off the chillers? That happens every other day by a dumb mechanic. Every other day.
That happens every time the SPs give one of the guys a ticket.
But I actually equate our approach to cybersecurity to how we would approach securing valuables in our home. Because, you know, as a good analogy, analogies are great. You guys are all teachers, you understand that. You know, if you need to secure valuables in your home, you have a couple options. One option is to go to Costco and buy a safe for $230 or whatever, and it's fireproof and blah, 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 and that's what most of us do. Alternatively, you could build an 8-foot wall with barbed wire around your house and frisk everybody who comes in and out and not buy the safe. And that's how most people are approaching cybersecurity. They're securing the whole thing instead of what's critical. And that's super expensive. DoD's been focused on open systems, and now they're focused on secure systems, and I'm pretty sure they're going to have semi-open, secure junk. Because at the end of the day, nothing's working out there. I've actually been at places where they've got a SCIF building that's it's DDC, not connected to anything. It's an island. To do anything in there, you've got to get into the building to do something. They're slapping a Jace on it and calling it more secure. And I argue with them at that and say, no, I don't care what you're doing on the outside. You know, their idea is they only want one port in. and they don't want to have to deal with 4 or 5 or 6 manufacturers, so a single manufacturer. So that's their love affair with that particular solution. But anyway, so that's what's going on. Again, just to update, you know, everything's performance specified now. We do have this commissioning thing that's happening, which is an interesting thing, and I'll talk about that in a little minute. But that manpower shortage is getting worse throughout the system, and the biggest problem is on the engineering side, which you guys aren't going to solve, but you have to react to that reality. I mentioned the cybersecurity as well. And now how do we maintain that, which is the other kind of resources that are out there. And again, in the 60s through the 80s, we had mostly pneumatics. And the pneumatics experts kind of grew out of the pipe fitter side. So it was basically, you have a very analogous to what happened in the tab industry. If you look at the tab guys, they're sheet metal guys that have a little bit more, you know, want to do a little more than banging sheet metal. And pneumatics, the pipe fitters basically had a brain where said, yeah, I want to go do this control stuff. And they were our experts. It was a real tough time in the 80s and 90s as we moved to electronic-based stuff. And your expertise with systems expertise was pneumatics, and I kind of lived through that time frame. Again, they were simpler systems back then. We didn't have quite the variability. This transition was, you know, a lot of challenges. There was a lot of overridden stuff back then. But you know, we felt good because we kind of just spent $10 million on an energy management system that had a 2.9-year payback, so we're gonna embrace that. Anyway, and now our focus in the last decade and a half has been on open systems. You know, I see the cyber thing coming up. Total lack of understanding of the procurement. Everybody's looking for that silver bullet. You know, I just want to spec BACnet, and I don't have to worry. Everything will just talk to each other. So I spent a lot of time in re-education of that perception. And but on the positive side, we have a new generation of control techs from what I grew up with. If you look at the basic skills of somebody who's grown up in the, you know, the information age, they have a bit different skill set than what I was dealing with, you know, back in the 80s and 90s. The DDC skills, I think, you know, you throw them out there, they're pretty basic. We kind of know what they are. This is kind of my short list. You know, the cybersecurity awareness is kind of a new one that is becoming a requirement of these folks, and it's kind of related to the networking side a little bit. To me, the holy grail out there is the system knowledge. It's not that, I think you guys probably do a hell of a job of the nuts and bolts, you know, and create good controls techs for the controls industry. The system knowledge is the big one, and I'll talk a little bit about that because it's related to the engineering side. So here's the reality of the design installation part of our world. Controls are performance specified, and the specs aren't very specific. Okay, that's really seems like a stupid statement, but if you read specifications, they're not specific in the important areas. They're specific in the unimportant things, like how many colors go on the graphics. Like no, seriously, read them. They're very specific in things that don't matter, but they miss the picture. And controls end up being designed built by the contractors. Bottom line, been like that for a long time. So the application engineer, the programmer, becomes key to the success of the project. We see all kinds of documentation challenges, and this is my limited gene pool theory in the controls industry, that there's just resources are just really limited. They've never been more limited today than ever. I just see people being ridiculously overpaid by contractors for their skill set today, which is kind of good. Very hard for the owners who can't compete with that. I think that's going to change. Personally, we've had an awful long run, and I think there's going to be a little bit of a hiccup here coming, and that's going to change the dynamics a little bit. Training's critical, difficult to get a system to work as planned, and commissioning to me is a reaction of a failure in the basic installation. Commissioning to me should not be necessary. I make most of my business is based on, if I look at what I do in commissioning, 3/4 of what I do is other people's jobs. If they did their other jobs, you wouldn't need to buy anywhere near the services. And controls was the early linchpin that started commissioning. Now we're commissioning everything. You know, landscaping, walls, Although I used to, I have a building enclosure commissioning consultant I work with, and very, very talented. And she remembers me saying, evidently 20 years ago, that building enclosure wasn't commissioning, it was inspection. And, but I look now at building enclosure because the Lead 4 requires at least a design review. People are starting to run it, to buy more and more of that. And I look at what's happening, and it's very analogous as what's happened in mechanical systems. You end up with a lot of different complex window wall sections that are kind of performance specified by architects who just throw it on the general contractor to figure out. You can get the glazing guy, the insulation guy, and you get the, you know, there's all kinds of people that got to work together. And it's, some of it's analogous, only it's a lot of static stuff. The downside on the enclosure, frankly, though, is you don't, you know, if HVAC's not working, you kind of find out pretty quickly. That stuff, it can be not working and you don't find about the failure 5 years down the road. So it's kind of interesting to see. But if I look at the cause, it's the liability. Nobody wants to take any responsibility for the performance of that system. So they performance spec the pieces and parts and just kick the can down the road, which is what's been happening in our industry for a long time. So, you know, here's just a picture schematic of an air handler, okay. Most design guys will put that out on the table and say, here's the points, here's the sensors, here's what I need. But, you know, the issue to me is always what happens inside the black box, you know, and so you don't see that to the shop drawings. And, you know, that's where the sequence is. And I always argue there's 4 sequences of operation. There's the original design document, there's the application engineer's interpretation of that, then it's turned over to the owner, and they say, I don't like to do it that way. They change it. And if they're more than 2 shifts, then they have different ideas, and it can be all kinds of different things. And they're programmed two primary ways today. Line code and graphical programming are the 2 most common ways. Still a bunch of line code out there, but most of the newer players are doing graphical. And I, you know, like that. This is a picture of a design document that I do of a cooling-only VAV box. An engineer will spec the sequence of a cooling-only VAV box in 1 sentence, usually, maybe 2, no more than 18 words. You know, here's a generic logic diagram for that box. Do you think there's any possibility you can, you know, describe that in 20 words or less? You know, so, you know, that's a problem. That's a real problem, is that engineers don't describe exactly how they think they want the thing to do. And I'm not expecting anybody to read this. I'm just sort of, you know, case in point. You know, here's for a whole air handler. And again, if you look at an air handler sequence of operation, it will be maybe 3 paragraphs, 100 words or less. And again, no way you describe everything going on in that logic. And a lot of it's the safeties and failures and what happens when the fan goes off and what happens, but that's part of it. Very few people do this today. And I believe that's a big failure of the engineering industry, which is the reason why I come back around to the system level knowledge that we need to give to our technicians. Because if the engineers did a bulletproof sequence of operation for the system, then the skill set of the programmer would just need to be a programmer. They would understand their system and how to program what you put in here, because they know it's good. But they're given a loosey-goosey, hey, it's control something like this, and that forces them to be the engineer on the job. That's the big hurdle, in my opinion. The big problem, I think, education-wise. The practical things are, you know, and again, these aren't slides just for you. I've used these other places. This particular slide, that, you know, it's not education and training, but it's experience-based. It's not something you can go to a magical 30-day class and boom, you got everything you need. A lot of proprietary. The open's another challenge. And you know, now we've got new things occurring. You know, seeing these people are really pushing the envelope with high-performance sequences. You know, a lot of changes over the years you guys are well aware of. You know, if you look at, you know, what was available, you know, in chillers 3 decades ago, or air handlers or fans or pumps, yeah, they've changed. But controls, you know, you can acknowledge your alarms on your smartphone. And back, you had pneumatics. I mean, we've made such a quantum leap in controls over 3 decades compared to the rest of the HVAC industry, and we really haven't changed how we maintain them. Look at this, all the stuff we're dealing with, which is totally different, which has happened. We had open protocol 30 years ago. We called it 20-pound air. You could take anybody's pneumatics and switch and swatch, and you can't do that in DDC. Today we are using these internet-based systems. The open protocol, that's just my kind of fun at poking at it with a whole bunch of caveats, which I don't think, if you really look at open systems, if you look at our industry makes 92 to 95% of their money off of their existing customer base. So is it a good business idea to open up your current customer base so anybody can put their systems on your systems? So do you think anybody's really serious about open systems on a vendor side? No, it's a bad business decision. So I don't think, is there a technical reason we don't have open systems today? Is there a technical reason? How many have put a security camera in their house recently or whatever, some wireless thing? I mean, there's nothing that you call a tech to install. It all comes in a box and you put it in yourself. Simply Safe or what other these folks are out there, boom, boom, put it in, I'll find you right, everything they've all figured out how to do that. Is there any reason why we shouldn't have that in our DDC world? Something like that. Yeah, it's all about the money. And when but we've been pushing this open stuff for 2 decades, and it's sold as a pure procurement solution, and it's not. But a lot of decision makers, their view of the DDC world is a thermostat on a wall. They say, well, why is this stuff so expensive and complex? It's just a thermostat. I go to Home Depot and get 3 different kinds of the same thing. Is really that? Now that's maybe an exaggeration, but they don't understand how this is part of the problem. Other trends, obviously more complex systems, more complex strategies. On paper, we're chasing every BTU. DDC systems still are inherently proprietary, at least at the programming level, if nothing else. And then we've got this networked systems are obviously commonplace, which means that's a whole other skill set, which is needed. And then the IT thing's kind of growing as an issue. And now we have integrated fault detection systems out there, which adds another layer of data interpretation, which is going to be interesting how that all plays out. The reality, from my perspective on all that, is persistence is everything. Meaning if we put in a system and we're retro-commissioning or we're commissioning it, we're designing a good system, and we can't get it to persist, we failed. Now, its persistence is not, I can't control that because that's on the operations side, but I certainly can educate, spend a lot more time and better turnover packages to operations folks. Because of the people who consume your students, you've got contractors, you have owners, and you have commissioning providers. The people who have the least amount of money is the owners. They can't compete with contractors and commissioning providers for talent. So they don't get the best, typically. And those are the folks that at the end of the day are the ones that are undoing all the good work others are doing. Maybe not intentionally, just happens. These going complex sequences, they need, I believe obviously entropy is higher with the more complex systems. Based on observation, there's probably science that backs that up. But the other thing that drives me nuts is how many times do we get to claim the same BTU savings? I mean, I know at MacDill Air Force Base in the late 70s, I put a time clock on our air handler and said, okay, I claim those savings. And then later on, somebody came in and put an energy management system because the pins were out of the clock and claimed those savings. And then somebody came in with a utility rebate program and said, hey, someone overrode the schedule, and I'm going to claim the savings again. And then an energy performance contractor came in again and said, hey, look, that unit's running 24/7. And like, wait a minute. That savings has funded 4 projects now. I'd love somebody to do a study of all the energy projects we've done in this country. It probably would prove that we can turn off 2/3 of the power plants, but we can't. So what happened to all the savings? We get them, we lose them, we do them again. I wish I wish I was exaggerating. You know, it's not. It's sad. You know, when it is what it is, so we ought to do it, right? But we ought to invest. You know, if it hasn't persisted multiple times over the last couple of decades, we might want to spend a little more time focused on the persistence, which is the documentation, training, education of the inheriting staff. You know, again, the focus is on, you know, how does this work on paper? A lot of people aren't looking at the longer term perspective. And I see the engineering nut is getting worse. You know, driven by liability. It's not getting better. It's getting worse. And they're performance specifying other things other than controls, but controls is the worst. And again, this is kind of where I bring it to the engineering. The systems level knowledge needed to be known by the installers and the operations folks, as they're being asked to do the engineering that the design engineering is not happening. And that's it's easy to say that, and I think many of you would agree with that. It's a hard nut to get to accomplish that, to do that. The career options for the DDC techs used to be 2, contractor owner, and now the commissioning provider is a 3rd option for that expertise. And in fact, I'll argue the commissioning industry's growth is making the owner's problem worse, because they're taking techs that might go work for an owner and would rather work on the commission because they can make more money. So we're actually all fighting for the same, and the owners are having a harder time getting those. That's basically what that says. They really learn. And just a note on certifications. You guys do programs. You don't. It's different. Maybe you give a certificate or whatever. I'm talking about the stupid certifications in my business for commissioning. You know, go to a 2-day class and you're an expert. Out here in California now, they're doing, and they pass some things where you have to be a certified person to functionally test a VAV box or a crack unit or that. That's just nuts. And that's the certain industry trying to, you know, collect the skill sets. You can't certify, you know, work ethic or experience. I kind of was front and center to this early on. I provided some of the questions to some of the certification programs in commissioning, and since I teach controls, they said, you know, keep it simple. All right, you know, nothing hard. Okay. So in my, you've sat through my 35-hour class, and in the very first hour, I talk about, you know, sensor controller, control device, basic things like control loop, simple stuff, direct reverse acting, yada, you know, basic questions. Sent them half a dozen questions. All of them declined, too technical. I got a copy of the first exam. How to conduct a charrette made it. So you don't need to know the technical knowledge to be a certified commissioning provider. You need to know the process. And we have probably one of the more technically demanding certifications in our industry is the TAB certification. If you look at the TAB certifications that are out there, if you look at what has to be proven of knowledge, they're fairly high compared to other things in our industry. Yet the TAB industry, we all know if we have a certified TAB provider, we get a well-balanced system, right? So much so that it's now part of the commissioning scope to double check on that because of the giant failure. So all the TAB certification did was commoditize the business. If you're all equal, why do I need to actually look at your qualifications? You all just told me you all are really good at what you do, so now I can bid you out. Same thing's happening in commissioning business. Bad idea. So anyway, some of this has gotten way out of hand on the pieces of paper that we can get. I always said when you have more letters after your name than your whole name, especially a name like D'Alessandro, I mean, you know, holy crap. You've been spending too much time certifying. And I've seen cards where the guy, got 15 letters, the guy's name, and 29 in the certifications. So what's the catalyst to change things? The engineers, I don't see any economic incentive for them to take more risk for no increase in fee, to do a better controls design, because they've taken huge risk, and I don't think they're going to get more money. I'm not sure, so I don't see a catalyst there. On the installer side, the good ones understand it's not a commodity, and they need to grow and keep their good technicians. Not all of them get this, and I actually gain in their stupidity in getting some really talented people that way, because they think that they're just a commodity, and I can just, I can replace my 50-year-old controls tech with two 25-year-olds and get twice as much work out of them. That happens in the industry. We could just send them to one of our, classes or corporate classes, and bingo, they're out and they can just do this stuff. So that's a problem. The owners, lower paid group, currently no motivation to change. The thing that's out there, maybe building performance metrics, force them to really consider things, because if they have performance metrics to hit, they're going to have to upgrade how they maintain their buildings. So maybe that's a provider. And then us on the provider side, we're really a reaction to the failure of that. And I can see some owners are using that as a way to help them, a bigger role of them, help the provider. So these are some of my favorite quotes on problem solving. You guys probably use them in some of your classes. Einstein had some really good ones. And we just need to really think about this differently. Keep kind of attacking it similarly, expect different results, and that's crazy. One of my other ones that has nothing to do with this, or maybe it does in an odd way, is when I researched his quotes, I found this one. Have you seen this one of Einstein? And which I think is really kind of a poke at people, but he had a sense of humor. I have this analogy I was going to take out of this, but I did in my last class, and I'll just include it since you were going to do that. But I always, from an operations perspective, I did this analogy for how we manage IT systems versus DDC, and I'll go through it quickly because you'll get the point. But IT stuff didn't exist 30 years ago, and so we didn't know how to maintain it because we didn't have it. So it was able to be created out of nowhere, and it has a whole. It's very similar if you look at, So I did this program to educate some decision makers at universities, and I just. Pick some sketches of IT systems, and I just, there's probably one that exists at Laney. You could probably say, here's the IT infrastructure for this college. And then you could pull up some BAS drawings, and networks, and say, oh, here's what the building looks like. And here's this building. And we got these network DDC systems, and they look a lot like the IT system. And you can even go get some software. This is for a software for my server at the office. And this is for a central plant down at MD Anderson. This is PPCL code Siemens system. Pretty complex little sucker. That's just for a central plant. And then we look at the organizations at a university, and I would imagine there's a very high level director here for IT here at Laney. You might even know him, Peter, I don't know. Probably makes pretty good money. Probably has a bunch of directors, a whole bunch of people. Probably has a budget significant to maintain IT in the college. And you can pick any. I mean, I don't know where these are from. I just grabbed IT networks at various universities, and they were all good-sized university. You have 60, 80 people. I didn't find their budget, but just doing the math on what those people make, it's not a small budget. And then I looked for the DDC. I looked for charts. This is honest truth. I said, okay, I want an example. I want to pick up and show that there's only a small group at this university, and I couldn't find an org chart. And so I went to images because I was looking for the org chart, and I found this picture. I said, well, that's appropriate. And it was this a DDC shop. At a Big Ten university, I found this one. 5 guys there. It's the University of Iowa. I know those guys. but I couldn't find there was no org chart. They're just sort of a subset, and the best you got was pictures. So those 5 guys or 3 guys are maintaining the whole DDC infrastructure, and then there's a formal group of a multi-million-dollar budget maintaining the IT. Now, could argue that they're not apples and apples, but they're fruits. We're in the same ballpark. There shouldn't be 2 or 3 orders of magnitude difference in the budgets to maintain them. So, why are IT important? Well, we live on, and without our IT system, our institution goes down. We understand that. I mean, people wouldn't be able to watch YouTube videos at lunch. I mean, the whole place would fall apart. DDC systems, if they're not working well, we have productivity issues. Not here because you're all well away because it's freezing, right? So not a problem. Space comfort. See, I did this just for this class. Energy, health and safety. We all understand the drivers, but we don't prioritize, this, we prioritize this, not so much. I think we're used to this being, and we've accepted it. And the other things that are happening, the IT organizations are new. DDC are not. We've been doing it for a long time, and we just kind of modified it, did the same way. So they're able to set. When do we buy IT stuff for a building? We build a new building. Does it go in with new construction? The cabling goes in, right? But then there's these empty closets. And so that goes, when you guys are done, finished, let us know. We'll put our stuff in there. So you've done the building, they come in and they put in, and you look, they have a whole different procurement methodology. Everything's sole sourced. They have their vendors or preferred vendors. They don't open bid that crap. It's all the same routers, all the same software. It all goes in, not part of the construction process. So they've changed the procurement rules because the others won't work well. If you open bid, if you performance specify the IT connection, they'd end up with a disaster too. So they don't do that. They follow a different path. So it's interesting. They've figured it out. And I use the IT versus DDC in an argument with contracting people a lot to try to achieve a better result for the institution. And we can also use their career path too. They basically allow people to be technical and make more money, and we kind of force people to become managers to make more money. We don't allow somebody to be a technical expert and grow in salary. They stagnate at a certain level, and that's a problem. It has nothing to do with anything that you guys can change. It's more of what owners have to understand. The experiential learning. So, back to more to your background here is if I've always been grappling with HVAC fundamentals, engineering principles for non-engineers, which they've learned it. I have a lot of non-degreed engineers that work with me, and they are pseudo-engineers in every way, shape, or form except for a 4-year degree. But they've learned it, so they've learned it experiential over the years. There's ways how do we teach that? And that was a struggle when I was in the Air Force. All of our students were college degreed engineers. So when I taught hydronics, I could say Bernoulli and everybody understood that. I remember I taught a piping design class at UW one year, and for whatever reason, the typical audience didn't come. And we had a couple consulting engineers. We had an instructor at a PhD who was teaching fluids and was looking for better ideas on how to do his class. We had a couple cross-trained electricals that were working for industrial that were being moved to mechanical. I didn't know a little bit about hydronics. And for whatever reason, I had 16 pipe fitters in the class from Chicago. And when I put up Bernoulli's equation, they were asking me what the funny looking P was. And that was the majority of my class. So I had to change how I taught that class. But my class was aimed at design engineers. It was the way it was structured. They just took it. And over the years, we have more and more of that in the general. I can't control who goes to these classes. But it always, I know there's a way to do that. It just takes time. Now I have some ideas. So, and it's not just the fundamentals of the basic topics. It's an applied. If you think of what we really need people to know, is applied psychometrics and applied hydronics for real systems. okay? And again, this is really, I don't think anybody disagrees this is important. This is how you all do this for a living, okay? That's really nice. How do you do that? And that's a challenge. And, you know, I've dealt with some institutions, none of the ones here, some community colleges in the Southeast in particular, where I just see an attempt to regurgitate existing material and come up with a new program and not doing anything original. And I understand that because I'm a teacher too, and I understand how much time it takes to develop brand new spanking material. So I get that. But you know, we've got a whole bunch of interesting technology, and we have a whole lot of experience out there. These are some pictures from David Sellers. David, how many have seen David's programs or have been to any of David's classes? David works with us, and I have. David's a funny guy. If you heard him, he introduces himself as head of our nonprofit division. That's what David does. So I let David do what David does, and David's created some virtual mechanical rooms, which are really incredible. He's got a blog that you can go to through my website, and again, there's all given away stuff. But he continues to use these SketchUp models, and he's built up plants, and he's basically built in his experience over the years in problems into this plant. The detail, I mean, he's got you can drill into that chiller and you can see nameplate data, and he's actually got the screen on the chiller, and it's a train chiller, TRAIN chiller with Moneywell controls, and I think anyway, he's just anyway, he's built into a lot of problems in there, and he uses it more for retrocommissioning and identifying, troubleshooting what's wrong with this picture, how can we operate this more efficiently. But he's also built an air handler type thing, and SketchUp is kind of an interesting tool, and I'm you're dealing with a 65-year-old who's learned how to do this really well, and he's got a unique skill set. David's quite interesting, but you start thinking of this platform, with other people who are a lot younger and quicker at this development, what you could create, and potential. We were talking about VR into this, to try to basically, is there a way that we can create? Because it's nice to get your hands on equipment, but there's only so much you can do, and that's very time consuming. Can we create the equivalent experience with this? And I just sit here and struggle with this, and I've been struggling with it a long time. And I just think what David's done with some other things that, maybe there's an answer out there somewhere. And all his stuff is available. He makes all his teaching material available, so there's a lot of stuff there via that, so it might be useful for some of you. On the end, the driver for all this is the owner. The owner's got to change their perspective. They like to buy the green roof that now leaks, and the PV, but hiring a higher grade tech is not in there. What you could do with being able to buy a higher end tech from a CO2 footprint is stupid. You can't even the math, but they'll come up with $1 million for a PV system in a heartbeat, or a green roof, or something else. Gray water recovery system, yeah, no problem. You know what I could do with a good tech on your campus compared to what that's doing? And it's just color's a money problem, but that has to change. I'm not sure when or will it was. And then they've got to understand this incent program to allow people who are good technically to stay technical and make money. Again, nothing that you guys can do with this, but I try to get owners to consider that. If they're really serious about their performance of the buildings, they need to up their game on what kind of people that they hire and maintain and keep. Persistence is everything. And again, if that the educational needs to supply that are key. Like I say, it blows my mind when I hear a little bit about what you all collectively are doing as a group, and you're only a small percentage of others that are out there. So it's pretty amazing. But I don't know how to grapple with that systems level challenge. And I know you're all doing it anecdotally here and there, but I mean holistically, I think that's the holy grail that we really need to go after. So that's my perspective, and hopefully it was somewhat useful to think about. And again, I know I'm preaching to the choir a little bit in this group, but I do preach to others in this industry a lot to try to orient them that way. So, questions, comments? Sure.
When I talk to people in management, and I don't mean the ones that only know what the thermostat is, like quite a bit smarter than that.
Okay.
But they say to me all the time, if our campus only had one proprietary system, how would we price check? The constant controls would just charge us anything they want for every single piece of equipment. So we have to have open protocol, and we have to have various vendors.
Yeah.
How do you feel about that, or what's your answer to that?
You know, I'm not a, there are certain places where I've argued for sole source because an institution had enough corporate knowledge to basically manage that smartly. I've done unit price contracts for institutions where they've sole source, so it's sole source with a GMP sort of number, if you will. So they know they're probably paying 20% more than street price, which I'd argue is probably worth it in most cases.
If they knew that.
That's
right?
correct, if they knew that. But I've seen places where it's 50 or 100, and that's not worth it.
Exactly.
Right, and that's what you're trying to protect. A lot of cases, I'd recommend a red, blue, green scenario where we just have multiple vendors. But we also agree that if we have a red building, it stays red. We don't do the third floor green. And to do that, sometimes when you do the design on the red building, you collect unit costs for, if you're only doing the central plant, and I do that a lot, we're doing the central equipment, but you don't have the money to do the zones. Well, you don't want to have vendor B do the zones. I just deal with this with a big corporate headquarters building, I won't mention the name of, but it wasn't Apple, it was a different, but they one locally. I just got hired to do, and they're doing they're doing the fit out, and the core and shell is done by another developer. And so that's going to be commissioned by somebody else, and they have a little bit of my time to make sure they turn over a working air handlers in central plant. I asked them about the controls in our kickoff meeting. I said, who's the controls? Well, we just heard it was Siemens was awarded the base building. Really? I said, do you have a unit cost for your 1,020 VAV boxes? No. I said, if I were them for the 8 air handlers in the central plant, I would have done that for free. Because that's like a couple $100,000 job, and your boxes should be about 1.5 million, but you're probably going to pay 3. And I got a deer in headlights look.
Yeah.
Because they hadn't thought about that. But they're committed now. Siemens got the base building. They're not going to want to put in vendor B on all the terminal units and deal with that if they just thought a little bit ahead. So now that, but people don't, you need to think, even if you're doing just a core, you got to think about the future shell, if you will, from a terminal unit. And that. So on that campus, there are other solutions that involve, they're not easy solutions, but I deal a lot with that. And also you never walk into the place where it's blind, where they haven't already sinned, meaning they've already got something.
No, right. Well, I've been at meetings where the techs are bitching about all the problems they have at Yale University. And the guy from Harvard says, oh, those exact same problems happen at Harvard, except it's worse because the IT department kicks you out while you're trying to fix it. If those places can't get their systems working together that mint money, what hope is there for anybody on regular budget?
Yeah, well, again, the do nothing option is a decision, right? We can all keep doing what we've been doing, and
right,
or you can attack it a different way. I've done some I've actually worked at Harvard and Yale and Hopkins, and I've dealt with sole source relationships that were sole source vendor A, without mentioning names, big vendors, who were tossed out of the sole source, and I was shocked to hear that because they'd already convinced the capital projects people it's worth paying a significant premium for this luxury at one of those,
right,
many of those institutions.
plus 20% that grew to plus 50%.
Or more, yes. And they changed, and the guy who was driving this on the inheriting side, I figured he retired. When I heard that they had, because I hadn't commissioned a job at Hopkins for 2 years, went there, and I said, so this is this system? They said, no, it's these three. I said, oh, did Joe retire? And they said, no, it's his idea. I went, and talking to him is basically sole sourcing, paying a 20, 30, 40% premium, paying your nummy, and getting regularly the C team.
Oh, yeah, yeah. Well,
And every time I've seen a sole source relationship go sour, and I've seen it more than a dozen times, it's because the vendors, thinking, oh, they're always buying for us, we can send them junior. And we need to send the A team over there where we need to impress a new customer.
new customers, yeah.
That's how stupid our
Like
industry
those
is.
friendly, knowledgeable clerks.
So
that
if you're a
do
sole source
big
provider
bucks.
to Harvard or Hopkins and you lose that, you're an idiot.
Right, that's on us, we gotta get them less juniors.
Well, the industry, right now, the numbers just aren't there.
It's not just our industry, though. You look at any provider, and all they're doing is chasing the new customers
Oh, yeah.
with the best deals. and,
That's just
you know,
human
The
nature.
guy who's been with them forever.
Well, why is that? Well,
Gets taken advantage.
the salesmen are overpaid. Yeah, that's just going on. But I mean, there is, you can do smarter things than do nothing and just sort of throw your hands up, we can't win this. There are ways to do that. And it's education of the capital projects and the procurement people. You know, it's a Pied Piper routine. You got to get people around the room who all have skin in the game and be willing to do something. You know, unit price contract for controls is not as easy as unit price contract for floor tile. I mean, it's a lot more complicated. It can be done. I've done it. It can be done, but it be done. A small institution probably doesn't have that ability because they don't have quite the money to do that. But a larger institution who's buying, you know, millions of dollars of controls every year, that makes a lot of sense. Yes, sir.
Is there any, like, you and I both know now, when you buy a computer, the hardware is nothing. That's the commodity.
Right.
It's the software that you're really purchasing that
Right.
comes with that computer. That's what costs all the money. Is there any indication the controls industry is heading that way, where you'll be able to buy hardware?
No, it's going to take, I've always said it's going to take someone from outside our industry to come into this industry. I mean,
But is
the
that
thing
what
that's,
Niagara trying to do?
if you go to the open thing, the thing that scares the big manufacturers in our business is the fact that somebody from Microsoft's there and Google's there and these other people are there. They're just listening. Nobody's placed any bet. I mean, Cisco jumped into our business. They bought somebody a couple decades ago. But I think I don't know what their attitude was, but I think they said, you know, it's ugly. I mean, you know, it's an ugly business. You know, how often do you replace a VAV controller? Every 15, 20 years maybe? You know, and how often do we replace one of these? Not often enough, if you evidently, recently, but they're making them too good or too expensive, whatever. But that happens. But you know, those things. You know, VAV box. You know, if TI made VAV box controllers, they'd stamp them out for $8 a piece and be happy selling for 20. So if there was an open protocol-based software that would let anybody's commodity stuff talk to each other, that'd be extremely valuable. But that's going to take somebody from outside our industry. No one in our industry wants to do that. So that's just my opinion. Yeah.
I come out of the consulting engineering business for 40 years, and I come back from the days of pneumatic controls as well. But I think when you mentioned, you know, competing for talent on the facility side, our work, so we did a lot of museum work over the years, and the museums would always get huge chunks of money for building new facilities, and part of that was always getting the best control system, the best everything, you know, because you had to maintain temperature, humidity. You would specify a gold-plated job. And then they had absolutely no money in the budget to even maintain what they had. I remember having, you know, the director of facilities calling me and said, you know, after about a year, we had a couple of control valves go bad. I said, yeah, so. He said, well, I gotta pay for them? I said, yeah, you gotta pay for them.
No, they last forever.
Yeah, that's right, exactly. They're gonna last forever.
Public
Now, those are the 100-year valves, I expect.
Don't wear public archives.
Yeah, well, yeah, that was our first job. Those boilers.
Not on this.
Anyway, any other questions? I think we have lunch waiting out there.